This is a video working through two homework questions from 11.5, number 10 and then number 12. Number 10 is giving you this slanted cylinder, and they're asking you to find the volume of the cylinder and then round our answer to the nearest hundredth. So volume for a cylinder, volume for cylinder, whether it's slanted or straight up and down, is the area of the base, so pi r squared. So that's the area of the base, often expressed as a capital B, times the height. And again, pi r squared, just because it's a circle. Looking at this particular cylinder, it looks as though they're giving us a circle that has a diameter of 12. So a radius would be half of that. So a radius would be 6. So I'm going to take and say, okay, that's pi times 6 squared. So I've got my area of the base, and now I need the height. The height's right here, and that's actually what makes this problem challenging. So the height is this piece on the right triangle. So to get that, I'm just going to grab this triangle and draw it right here separate. I know it's not quite as well free-handed, but that's all I know about it, right? So I've got the 60, I've got the 90, and I guess we know there's a 30 up here because that would make 180 degrees in the triangle. Then it's hard to figure out what to do from there. What I'm after is this side. So I want the height. And to get that, what I have to actually use is this 18. That 18 is a matching on the other side, which is this part of the triangle. So that 18 is the hypotenuse on this particular triangle. And you would have to make that connection or make that jump. From there, we can get the height. You can either use a trig ratio or you could use special right triangles. The quicker way is if you can remember the shortcuts on a 30, 60, 90 that get you from a hypotenuse to the other side. And if you can't remember it, then using a trig relationship. And I always go back to those basic trig relationships. I would use sine here. So I'd say sine of 60 is opposite h over hypotenuse 18. And then I would multiply both sides by 18. So 18 times the sine of 60. And for our purposes this year, that is not something you're required to memorize. If you're in advanced algebra trig setting, you would need to know what the sine of 60 is. But for us this year, being able to set it up and just understanding that that's the way you solve it is okay. So then I would pop over to the calculator and I would do 18 times the sine of 60. Give us what that height is. So 15.588. I'm just going to leave that whole number in there. I'll call it 15.6 just for plugging in purposes. But again, I'm going to leave that whole number in the calculator. So that's the height on this triangle, or on this triangle, which is the height on the cylinder. And then I'm going to take that number that's in the calculator right now, and I'm going to multiply it by pi, and then by 36, which is what 6 squared is. So 6 times 6 is 36. So I'm going to go that number times pi times 36. So I'll do times pi, and then times 6 squared, which is 36. And hit enter, and I get 1763.01. And that is to the nearest hundredth. So 1763.01. And we're talking meters here, so that's meters cubed. Are we on volume? We're on volume. So meters cubed. And that's it. So I think the hardest part is just nailing down what that h is and understanding how to pick that out of the picture. But that would be solving number 10. So finding the volume of this particular cylinder. The number 12, kind of scroll down here. No picture on this one, so they just said a pentagonal prism. So it means it has a pentagon or 5-sided base. It has a height of 9 feet, and each base edge is 3 feet. Find the volume. Okay, so let's see. We've got a pentagonal prism. That's tough for me to draw. So I'm gonna, let's see. Pentagon looks something like that. And I'm not great on doing perspective, but let's see, something like this probably, right? And whatever, I've got my pentagon in the back. Boy, it's hard drawing that perspective. Let's see, that looks all right, that looks all right. Yeah, I mean, not the best pentagonal prism in the world, but you get the idea. There's a pentagon here, and there's a pentagon here. You can stand it up, you can lay it on its side, whatever. That piece isn't super significant. It's got a height of 9. In other words, it goes 9 this way. And then each base edge is 3. So all these edges on the Pentagon are 3. And again, thinking through our volume equation, volume is always base times height. Well, I've got area of the base times the height. I've got the height, that's 9. I need to come up with the area of the base. So basically what this question is asking is find the area of a pentagon that has base of 3. So we got to come up with some way to do that. So some way to come up with the area of a pentagon where the base is 3. Okay, so to actually get that amount, we've got to come up with the area of a regular 5-sided shape. And we did this, I think, 2 sections ago. Maybe it was just, 2 sections ago. The area of a regular shape is half times the apothem times the perimeter. Perimeter on a regular shape is not that difficult. That's 3 5 times. So the perimeter, let me scroll up here. The perimeter is 15. The apothem, that is a tough one to get. And I'm going to switch colors for that. The apothem is from the center on this thing. And again, every regular polygon can be centered inside a circle where each vertex touches the edge of the circle. The apothem is going to get drawn straight down at 90 degrees, right? And then so we've got this radius of the circle, and again, when I'm referencing a circle, I'm going to try to draw it in. It's hard for me to freehand it, but that's a regular polygon will fit inside a circle where it's inscribed. And ultimately what we're after is if we can come up with that height, that kind of shaky line I drew in there where it's at 90 degrees, there's our apothem. And so if I can come up with that distance, I can pop that in, get the area. That's going to then fill in for this area of the base, and I'll have my volume. So we need to come up with what that apothem amount is. And to do that, I'm going to zoom in on just that triangle. So this one right here. We know that base length is 3. I've got that height right there. So I know that's a 90. And right now, that's all I've got. I mean, it's I think pretty obvious, but that means the triangle gets split into a 1.5 and 1.5 on the base. And ultimately, I am going to drill in and just look at one of these. So I'm just going to look at that one because I'm after this height on this thing. If I knew any of these angles other than the 90, we could do it because we could use a trig equation, or if I knew what the hypotenuse was, we could do it, which would mean I need to know the radius of that circle. The easiest thing, or the thing I'm going to be most likely to get, is going to be an angle on this triangle. So if you think about a pentagon, and if we were to draw in a few of these, so boom, 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 there's 1, 2, 3, 4, 5 of these triangles. So what that means is that there's 360 degrees to use up on the inside. I'm splitting that 360 degrees 5 ways. So if I divide 365 times, I'm going to get those 5 equal central angles. Those are each 72. That means this angle up here is 72 degrees. If I split 72 in half, that's going to give me this one right here to be 36. So that's a 36 degree angle that I just marked in there. And that is simply saying, hey, I've got 5 of these triangles that fit in there. I'm inside a circle, which means I got to use up 360. So divided by 5, I get 72. Then I'm going to split that triangle in half, and that's going to take that 72 and give me 36 degrees of it to be this upper angle up here. And then what I'm going to use, and you can use either of these. I mean, that's a 36, that's a 90, which means this one down here would be a 54 degree angle, and that gives me my full triangle. I need opposite and adjacent, so I'm going to use tangent. I'm actually going to use tangent of 54 equals opposite, my apothem over adjacent, 1.5. Multiply both sides by 1.5, and I've got 1.5 times the tangent of 54 is the apothem. And again, all of this work just to get this little guy right there. So 1.5 tangent of 54. 1.5 tan of 54. I think that'll do my multiplication for me. So there's 2.064. I'm just going to leave that whole thing in there. So let's call it 2.1 just as a placeholder in here. So 2.1 is my apothem. And again, I'm just going to leave that number in there, and then what I'm going to do is take it and multiply by 15 and multiply by a half. So I'm going to go times by 15 times by 0.5 and hit enter. That number then, 15.484, and again, I'm going to leave that number in there, so 15.5, let's call it. That's the area of this pentagon. All of that work just to do this. So now I'm going to say, okay, well, volume is the area, that number times 9. So let's do that. That number times 9. So I just need to hit times 9. And again, let your calculator hold on to the decimals. Don't round till we're all done. And we get 139.3586, so 139.36. So 139.36, and I forget our units here. We're talking feet, and that's feet cubed. And that's it. That's how you work through this one.